Hello everyone, welcome to a new class on design patterns, and in this opportunity we're going to be talking about the adapter pattern. Now before we go to the adapter pattern, it is very important to mention that this is actually the first structural design pattern that we're seeing in this course. So up until now, we've been talking about creational design patterns, which are in charge of creating new instances of classes, creating objects. But in this case, we're going to stop talking about that for a little while, and now we're going to look at how we can structure my code. My structural design patterns are going to be a little bit more focused on the structure of the code, the big picture of how the code is going to be assembled. So I found this very interesting definition in the Refactoring Group web page that says that structural patterns explain how to assemble objects and classes into larger structures. So we're looking at the big picture of how the program is supposed to be connected and integrated, while keeping these structures flexible and efficient. This is one of the basic cores of coding. You want to keep your code simple, clean, but especially flexible. Things that allows you to modify and grow your program as much as you can. Now, let's have a look at that adapter pattern. So the idea of adapter is exactly what it sounds like. So I'm going to give you a real life example, and then we'll define the adapter pattern in a second. But suppose you live in Ireland, you've been living in Ireland for a while, so probably all your appliances, your computer has the Irish socket to connect to the power on the wall. But if you travel to Spain or Greece or Germany, the sockets that they use over there is a different socket. So in order to use your Irish socket in there, you need to get an adapter. So that adapter is going to be exactly the same thing in computing programming as a design pattern. So what it's going to do is it's going to offer me a way that I can get two unrelated systems to work together. Particularly when you have systems that for some reason they're not designed to work together, but you want them to come and to work together. So that's exactly what the adapter pattern is going to do. So let's have a look at an example that is a little bit more programming oriented. So suppose we have two companies, the company A and company B, and these two companies are merging together. They are being a new big company now. Now, each one of them will have their own system, their own legacy code. And the code between the two classes, between the two companies, is not quite compatible. So this is a very good example in which I can implement the design pattern and put it in order to make these two companies to work together. Actually, the example that we're going to be doing coding in this class is exactly that. So I have given you in the pre-class version of the code a few classes in there that you can use. So we have a company A, a company B. We have a company A interface, an employee A interface. We have an employee A, and we have an employee B interface and an employee B. One of the things that we're going to notice is that the company A refers to its employees as employee A interface as opposed to the concretion. So company A talks to the interfaces, and the same thing happened with company B. Company B talks to the employee B interfaces. So the code is well structured to the abstractions as opposed to the concretions. So let's take a look at this code and make sure that we actually understand what we have in there. Yeah, take a look at this. So we have a company A class, as you can see there. The company A has an array list of employees, and those employees are of the employee A interface. This is what I meant saying that this is as the client class is coded for the abstraction as opposed to the concrete classes. And it has a method that it lists all the employees that I have for this particular company. Same thing happened for company B. It's exactly the same thing. It has an array list of employees, and it has a method to print all the employees. But let's take a look at the interfaces. For my interface, employee A interface, I have a set name, a get name and a set name method. I can see that this class is going to have a name attribute. But then in the employee B interface, I have a get full name and set full name interface. So this is where I see the differences. These two classes are fairly incompatible because the name of the attribute is not exactly the same. Now I could rewrite the code, but that's something that in computer programming we avoid to do. We don't change legacy code because we don't know what we're breaking. But what we can do is try to adjust something to adapt these two patterns. Now let's take a look at the concrete classes for a second. Attribute name, getters and setter and constructor, nothing special. Same thing with employee B, attribute, getters and setters, nothing special. Now in the main class, this is a code that we can already try the test. In the main class, I am creating an array of employees. I'm populating that array list with some employees in there, and I'm creating a new company A, passing in the list of employees, and then printing, and likewise for company B. So if I run this, you should be able to see that my company A has 5 employees, and they're of the type employee A, and my company B has 5 employees of the type company B. Now, what is it that we want to do? We want to try to find a way to make company A to work with employee B. So I'll say that again, we have a company A, and I don't want it to work only with employee A, I want it also to work with employee B. And I'll give you a hint. You will need to create a new class. You can call that class employee B adapter. So what we're going to do is we're going to address this in 2 ways. We're going to see a class implementation of this pattern, and we're also going to see an object implementation of this pattern, and those are going to be the next 2 videos. But for now, I'm going to ask you just to try to give this a go. So before you go to the next video, give yourself a couple of minutes, 10-15 minutes, and try to do this implementation yourself. Thank you for watching, and I'll see you in the next one.